Well, Math 151, a rectangle is inscribed with its base on the x-axis and its upper corners on the semi-ellipse defined by x squared plus 5y squared equals 9. In the quadrants 1 and 2, find the greatest possible area. And so let's see, here's drawing. I know my drawing doesn't look like a semi-ellipse, but that's the best I could do with my iPad. Just work with me on that, please. Okay, so we know that the equation of the ellipse, okay, is according to the given problem is x squared plus 5y squared equals 9. Okay, so let's see this distance, the height of this rectangle that we're trying to maximize the area is y, and this distance from here to here is x. So the area, so if that's the case, notice that this distance right here, this size for the entire rectangle is going to be, if I pull that out of the semi-ellipse, 2x by y is the area of my rectangle. And I'm going to, so I can claim that area of the rectangle equals 2x times y. So now I do have two equations. The ellipse is not going to change. So this is my constraint, but the x and y, I haven't, I can play with my x and y. I can make the rectangle different sizes. Okay, so I'm going to solve here from the first one, from here. I'm going to solve for y and then substitute it in here and then take the derivative to see, to find my maximum and minimum, in this case, the maximum. Okay. Let me go to the next page. X squared plus 5y squared equals 9. Solving for y squared, I get y squared equals x squared, or 9 minus, subtracting x squared from both sides and then dividing by 5. And so if I take square root of both sides, now I do have y equals square root of 9 minus x squared over 5. I'm not going to do the plus and minus because we're working with geometry. I'm going to go ahead and ignore the negative root. Okay, so y equals 9 minus x squared over 5. And we knew that area equals 2x times y, and I can now substitute this into here. And go to the next page. So I have area equals 2x square root of 9 minus x squared over 5. Now, because I want to take the derivative, I'm going to rewrite this as a equals 2x 9 minus x squared over 5 to the 1/2. That makes my life a little bit easier. So a prime, or a prime of x equals, this 2 right here is a constant. So I'm going to just keep it out. The derivative of x is 1. 1 times 9 minus x squared over 5 to the 1/2. I'm going to rewrite this as 9 minus x squared over 5. Okay. And then I'm going to have to, then taking the derivative of the second part times x. So I'm going to have plus x times 1/2 9 minus x squared over 5 to the negative 1/2. So now I have to multiplied by the derivative inside of this parenthesis. So 9 minus x squared over 5 is the same as saying 9 over 5 minus 1/5 x squared. And what is the derivative of that? The derivative of this is nothing. The derivative of this is minus 2/5 minus 2/5 x. Okay, and let me close the bracket. Let me close the bracket. I'm done with my derivative. So let's just put this in a neat way. So a prime of x equals 2 times square root of 9 minus x squared over 5. So I do have a negative here. So this becomes negative, okay? X times x is x squared, okay? And I have a 5 in the denominator right here. So I'm going to put the 5 in the denominator. And I'm going to put this also because it has negative exponent. I'm going to rewrite this as 9 minus x squared over 5. So notice that now I have to combine these two and set it equal to 0. So I'm going to go ahead and multiply both sides of, multiply the top and bottom of this by my LCD. Going to the next page. So I have a prime equals, here's the 2 I had. So notice that I had, this is what I had, 9 minus x squared over 5. And then after that, so let's just put that over 1. And what else I had? I had minus x squared over 5 times square root of 9 minus x squared over 5. This is what I had. So now I'm going to multiply top and bottom of this one by 9 minus x squared over 5 square root of 9 minus x squared over 5. So now I'm going to get a prime equals, here's my 2. So on the numerator, the square root goes away. So I'm going to have, oh, and I need a 5. I need a 5 in here. So multiply this by 5 times that. So on the numerator now, I'm going to have 5 times 9 minus x squared over 5 over, just minus, okay, x squared over, since I'm not going to, oh, let me write it, that's okay. 5 times square root of 9 minus x squared over 5. All right, so notice that right here, I can cancel this 5 with this 5. So I'm going to go ahead and go to the next page. I'm going to have a 2. So I'm going to have a prime. Let me change color. A prime equals 2 I had. And so 5's canceled out. So I have 9 minus x squared minus x squared all over. And I'm going to just put a d for denominator because I'm not going to do anything with the denominator. Nothing is canceling out. And so a prime equals 2 times 9 minus 2x squared over the denominator. And now I'm going to set this equal to 0. Set equal to 0. It is enough, sufficient for the numerator to be 0. And so I'm going to say 9 minus 2x squared equals 0. So I have 9 equal 2x squared, and this implies that x squared equals 9/2. And my iPad is giving me a hard time. So if I take square root of both sides, so I have x equal plus and minus square root of 9/2. Once again, I'm going to go ahead and just ignore the negative because it's geometry. So that equals square root of 9 is 3/√2. So x equal, so when x equal 3/√2, now I need to find what is y when x is 3/√2. Going to the next page. So remember that we had y equals square root of 9 minus x squared over 5. I'm going to use that. So that equals square root of 9 minus 3/√2 squared on over 5. So y equals square root of 9 minus 9/2 over 5, and 9 minus 4.5 is 4.5 over 5. So let's put that in a calculator, and square root of 4.5 divided by 5. Okay, so I have this as 0.94868, 0.94868. And so area equals, remember our job is to find the largest area, 2 times x times y. So this equals 2 times x is 3/√2. X is 3/√2 times y, which is 0.94868. And 2, 3/√2. And all that times 0.94868. Okay, and according to my calculator, I get approximately 4.02498. Okay, thanks.